Kia ora Year 12 and 13. This is going to be a really short but very slow video on how to use special triangles to find exact values for trig. So these turn out to be very useful in level 3 trig problems, but some people seem to have trouble remembering where they've come from. So we're going to go right back to Year 9 geometry to take a look at that first. As usual, the drawings are going to be bad, but just when you're doing them in your book, please use a ruler or use a snapper card or an ID card. So if we think about this triangle, this is an equilateral triangle, and we're going to say that it's got side lengths of 2. So what does that mean we can work out? Well, an equilateral triangle has all sides the same length and all angles equal. We know that the angles have to add to 180, so each angle will be 60 degrees. So we can write that in there, 3 angles of 60 degrees. So here's the lovely magic trick that gives us a special triangle. If we take a ruler and we chop the special triangle in half, we can get a new triangle. We can work out what we know about that. Well, we know that this side must be 2 units long, and this side here is just half of that one. So half of 2 is 1. This angle here hasn't changed, so it's still 60 degrees. We've got a right angle here, and that means that up here we must have an angle of 30 degrees. If they, and that's because they all have to add up to 180. Okay, so far so good. So we're just about finished. We've found 3 angles in that triangle and 2 side lengths. The only thing left to do is to figure out the length of this side. Now we've got a right angle triangle and we know 2 side lengths, so we can get the third one using Pythagoras. So 1 squared plus, we'll call this x squared is equal to 2 squared. That gives me x squared is equal to 4 take away 1, which is 3, giving me a side length finally of x equals root 3. And we can now put that onto our special triangle. So this is the first of the 2 triangles. On the next slide I'm going to look at why that's any use to us. Okay, so let's draw out special triangle number 1. Remember, this side length is 1 unit long, this one's 2 units long, and we figured that this must be root 3 units long. The angle in here is 60 degrees, and the angle up here is 30 degrees. So that means that we can use SOHCAHTOA to figure out all the trig ratios that we want to. So sine of 60 degrees is going to be root 3, because that's the opposite side, over 2, because this is the hypotenuse side. Cosine of 60 degrees will be 1 over 2. Right, it's 1 because this side length is the adjacent. And lastly, tan of 60 degrees is equal to root 3 over 1, which is just root 3. Now we can now look at the triangle focusing in on the angle that's 30 degrees, and we can generate sine, cos and tan for 30 degrees as well. So I'm going to do that down here. You should pause the video now and see if you can do that without any help from me. Okay, so here's what you should have got. Sine of 30 degrees is going to be 1 over 2, or 1/2. Cosine of 30 degrees is equal to root 3 over 2, and tan of 30 degrees will be 1 over root 3. So let's just look again at the triangle and where all those came from, in case you had trouble with that. I'm going to see if I can erase these. The trick here is that whether something is the opposite or the adjacent obviously depends on what angle we're talking about. So now that we're switching over to doing 30 degrees being my angle, we need to relabel our sides. The opposite side for 30 degrees is here, and the adjacent side is root 3 here. The hypotenuse hasn't moved. So when we look at SOHCAHTOA, that's how we generate the set of values in here. There's one more special triangle that we're going to look at next. Suppose we have an isosceles triangle that looks like this. We've got side lengths of 1 and 1, and we've got a right angle. Now we know that the base angles in an isosceles triangle are equal, and the angles have to add up to 180. So that means that this is 45 degrees, and this angle is also 45 degrees. The last thing we have to work out is the length of this side, and we can do that using Pythagoras' theorem. So 1 squared plus 1 squared is equal to, let's make it x again, x squared. X squared is 2, so the side length is root 2. Now it can't be negative root 2 because I'm dealing with a length, just in case you were wondering why I got rid of the negative root. Okay, so now we do the same thing as before. This time it's easier because we've only got one angle, which is 45 degrees. We start by labelling. So this is the opposite side, this is the adjacent side, and this is the hypotenuse. What does that get me? Well, we can say sine of 45 degrees is equal to the opposite, 1 over the hypotenuse, root 2. Cos of 45 degrees is equal to 1 over root 2. And tan of 45 degrees is 1 over 1, which is just 1. Okay, so here are 6 questions for you to practice. I want you to draw and then use the special triangles to figure out these values of trig ratios. I've put radians into questions 4, 5 and 6 because you should be able to go comfortably between degrees and radians. And I don't want to spend time going over that in this video because it'll get too long. Now, because this is my 300th video, there's a special giveaway, which is a chocolate bar to the first person who's watched this to here and emails me in the answers to those 6 questions. Okay, and I promise I will actually come through with the chocolate. I've got it sitting on the desk here at home, and I'll put it in my bag and bring it to school tomorrow. So first one to get that done gets the chocolate, and here's my email address to send the answers to. Alright, thanks for watching. Hope the trig revision's going really well.